Our keynote presentation is coming. It's called Leveraging Big Data and Analytics, and it's delivered by Dr. Satyam Priyadarshy. He's the Chief Data Scientist for Halliburton. And I just want to, I'm not going to do a big introduction for him, but I was checking him out on LinkedIn, and you should too. And here, don't you want people to say things like this about you? One of the best known people in high tech industry. Yeah, that's okay. He's nice. He's cool. He's friendly. I love working with him. Another person said, a great teacher doesn't need much outside himself to inspire the next generation. He stands before the class and shares his expertise. I've only met him for a few minutes. I think he's a great guy, and I'm going to turn it over to him now. Dr. Satyam, it's all yours.
Good morning, Jim. I hope I'm audible.
You are indeed, sir.
Okay, perfect. And I'm assuming that my slides are visible as well.
Yep.
Okay, excellent. Good morning, everyone. Good afternoon, good evening, depending if you are coming from some other time zones to attend this session. First of all, it's a great honor to be here. And I wish, even though I'm virtually in Canada, but I would have loved to be in Canada in person. That would have been really good. But at the same time, we have to live in this virtual world now, which is perfect. I thought what I will talk about is for last couple of almost I would say 15, 20 years of being in the space of big data analytics. Well before people actually used to talk about big data, I share some of the learnings that I have during this journey that I have. This was the abstract that was put up in the talk. Main thing is like, what is the challenges with big data and why people are not able to create value? And I'll illustrate it with the example, at least for now, from oil and gas industry, and another one from cybersecurity. Hopefully that will help us understand how to actually move forward. Since it's a video call, I don't have to show my picture there, but this is roughly the picture that I want to talk about. That is, what's the big picture? Why are we talking about big data and other things? Where does it fit into the whole spectrum of Industry 4.0? And what kind of talent is needed in some sense to actually leverage big data and how the value is created? But before I go on to actually go give the talk, I'm thankful to the Strategy Institute team that invited me to speak, and of course my PhD advisor and primary school teachers after my parents who enabled me and educated me to be able to speak here, and the work of last 20 years with a lot of teams in different industries, and of course my family, which allows me to travel when I was traveling in the last 6-7 years. Since my background is I'm a quantum physicist or quantum chemist, turned into a technologist, turned into executive, and now having fun at oil and gas industry, transforming an industry that really needs transformation badly in the energy space. And why is that? It's not only just oil and gas industry, which is actually impacted by energy transition landscape. It is actually every industry vertical, every organization, which will be really impacted by how this energy transition landscape evolves. As you can see with this so-called cartoon landscape diagram, this energy transition landscape is going to be as complex as this diagram. You don't know at which country will fall in which local minima or which because there will never be a global minima for this or global optimized solution for it. So in order to really create value for your own organization, this becomes an important aspect as to understand that that the energy transition landscape is going to impact all of us. And that is one of the reasons why Industrial 4.0 revolution framework is very, very important for all industries. And as we evolve into the Industry 4.0 revolution, we have to start building a disruptive growth in almost every industry. And this requires digital maturity for all organizations. Typically, most of the work that is being done in industries is in this left hand side corner, where people are trying to build some AI model. Some people call it ML model, somebody will call it data science model, somebody will call analytics and things like that. There's a whole slew of terms that people are using it interchangeably as well as confusingly at many times. But in order to really, for any industry to be really mature, main thing that is important is that can we do real-time resource optimization, whether it is people resources, whether it is technology resources, whether it is the resources like hydrocarbons, whatever it is. But in order to achieve this kind of maturity, one really need to adopt emerging technologies that are coming up, that are growing and evolving faster than we can actually tame them. And once both those two aspects are actually combined, this will lead to what I call the disruptive growth. And this disruptive growth will come as this digital maturity and economic value grows simultaneously. And the foundation of that actually lies in what I called big data. And this is a simple diagram that refers to these three terms that people use quite a bit: digitalization and digital transformation. But most of the work that goes on in most industries in digitalization, very few people are doing digital transformation, because it is a continuous transformation that is needed. And as a result, we are like way behind. And that's why one of the reasons why big data projects don't go through. The best way to explain this digital transformation or the grow or leverage of big data is example from music industry, that of course all these logos are owned by these companies. This is only used for education purpose here. You can see that originally digitization took place when we put audio onto the tape or onto the LP. Then we miniaturized the technology and we were able to actually move around. And then now today we actually do what is called streaming music. Now, if I actually click on it, you can see that this is what I call digitization. This is I call one aspect of the ecosystem that has been improved and efficient. That is, you can actually walk around with your music instead of carrying that big record player. And now today you can actually share your songs with anyone in the world without actually sending them a song. This is called a business transformation, and this is an example of a digital transformation. As we all know, that economic impact of this has been significant, right? During the era of this record player, we had very limited artists and very limited companies which made money, but as cassettes came, more and more companies, and today, we artists are born pretty much every day, and the amount of employment that has created in the industry is significant, far more than what was there in the record player times. So as the technology adoption has taken place, number of jobs that have been created have been significant. So this is but the foundation, as I said, lies in big data, and because these are the four pillars of digital transformation, irrespective of the industry. One is, how do you leverage big data analytics? How do you integrate technology? Can you do real time? And can we automate the systems? If you actually could, you can actually map the journey of streaming music along these four pillars as well. Now, what the fundamental is, foundation, as I said, is big data. And what is then big data? A lot of people actually are, if I asked, almost everybody will actually tell me that they know what big data is. But according to me, what most people actually describe big data is like this story from Panchtantra from 300 BC, where 6 blind people are describing an elephant and the body part that they touch of the elephant and what they know. And in the same sense, in the same spirit, that's how people define big data. There's lots of data lakes, 3 Vs, 4 Vs, 5 Vs, 32 Vs, depending on who you are talking about. And then if you want to act a little bit more educated and challenging, then you can say big data is about Hadoop. There were articles a couple of years ago when they said big data is Hadoop, and everybody wanted to implement a Hadoop solution in their company. And so then, of course, today we can talk about deep learning, machine learning, etc., etc. But then if you don't want to do anything, then you can say it's a buzzword. And this is where the fundamental flaw happens, because you talk to some companies and they say, oh, can we do some optimization of workflow, or can we build some predictive engine? We can leverage big data solutions, and they will say, oh, we don't have any big data issue at all. We have very small data. and that's whole concept breaks down in that case, because big data is not about lots of data. Actually, it is a term that has been used, but it's a business paradigm. In my experience, big data is basically, it's about all the data. That means the historical data, the current data, and the future data. It could be it could be as simple as kilobytes of data to petabytes of data. In our case, for example, the metadata related to a IoT sensors could be only in kilobytes or megabytes, but the metrics that they are sending from the field could be in terabytes. So, if I cannot connect the metadata along with the metrics that is coming, then it is of no value. So that means we should really know how to actually pipeline the data, and the data can be any kind. It could be audio, video, that signals we are doing. We are collecting seismic data, for example, taking pictures. All those can be there, and data can be anywhere in today's world. It doesn't have to be in my laptop to actually analyze, or on my workstation. And that's why this data pipelining is very important. As I say, in oil and gas industry, we are good at pipelining the hydrocarbons, but the challenge to pipeline data is actually harder. But in order to do that, uh, we have to really leverage all the technologies that are evolving, and leverage the full analytics value chain. Not every process needs deep learning, but at the same time, you really need to remove hidden and inefficiencies, so you can create the business value. So if I summarize that, my definition of big data is actually very simple. It is creating value from all the data by leveraging emerging technology and complete analytics value chain, so that we can remove hidden efficiencies and build actionable insights, so we can grow the business through a continuous data driven process. And this really requires a paradigm shift, a different kind of thinking, art of pattern recognition, and then always focused about stakeholder value, which could be many things to many people, but always value has to be there. And if I think of an example, here is a nice picture of data, and my question to all of you is, like, what do you see here? I'll give you 30 seconds. So maybe I won't be able to see your chat, but you can probably write in the chat window, and I'll catch up with you in a Q&A session. But what do you really see here? And as a data scientist, I only see black and white pixels, but some of you might see other things. So give 30 seconds, and then I'll ask my second question. All right, so hopefully you figured it out that there are some patterns in it, and according to those patterns, how many animals or insects or birds do you see there? The reason why I show this slide is that even though it looks very simple, it's a black and white pixels on a screen, and it forms a pattern. It is hard for us to really find all the patterns that exist. And especially in big data analytics, it's all about pattern recognition. Can you really figure out all the patterns that are created in the data, which we can actually, which will actually help us improve the business? So I'll look at your answers later on. And here is, if you didn't find all 13 animals, you can see what you are missing. All right, so now let's move on to real world, and we'll talk about how big data actually impacts, say, for example, oil and gas industry. It goes across the whole spectrum, upstream, midstream, downstream. If you can think of it, we have like petabytes of data, significant amount of unstructured data that is created, and you can actually see every aspect of that can be actually take advantage of big data analytics. And again, there is no one perfect solution, but each one of them, you have to build unique solutions for it. And especially if we look at upstream, what are we trying to do? What we call is, how can I reduce the time from planet to the pore significantly, from say 2 years to few months? That could actually change the game. In refineries, do we really need to have shutdowns on a scheduled manner, or can we do more dynamic shutdowns of the right portions of the plants, so that it reduces the cost of shutdowns? and keep their productivity increase. Of course, in downstream, you all know that it is like any other consumer-based approaches that can be actually applied to the downstream. But all these are relying on the foundation of big data analytics. I've written a lot of it, but most important part that I talk about is this 7 pillars of big data, what many people would call it as V. I really don't really talk them as variables, but they are actually the pillars: volume, velocity, variety, veracity, and virtual, because uh, anything from small to big. And if I look and compare with industries that I have worked in the past, then if you look at it, how that changes is I think I lost the option to change my screen. Okay, there is. If I look at different industries, how these pillars change is. If you look at volume in terms of oil and gas industry, we get significant amount of data, say in the exploration phase, but the value proposition is significant compared to e-commerce or social media. Different aspects in the velocity. Velocity where the data is coming real time is much smaller, whereas in social media everything is real time. So when we are building these solutions, the right combination of technology has to be used to address the challenge that we're talking about. And this is where one of the gaps that people see, that they want to take one solution from one industry and put it on another industry, and that doesn't work, and then they say the big data project has failed. And if you look at statistics from consulting companies, they will talk about X% of projects failing, X% of projects not making to the production, but the underlying reason is that one has not thought about customized solutions. And then as I said, that one of the biggest thing that you can do is actually connect the data, which is virtual. That means data can be in any different places, and how do you take the right elements of it to actually create your actionable insights and create new patterns that will allow you to actually change the business value. And this is the concept I describe as a data pipelining concept. And it can be done today with, especially with Kubernetes and Dockers being available so easily, that one can actually leverage this concept very well, and we actually do it in practice. I'm going to skip this slide as a history of analytics. Anyone interested, we can share that one later on. But the leverage of analytics have been there for last 100+ years. But this requires a new kind of mindset. It is more about being an entrepreneur as well as an innovator, to be really looking at patterns from the data, and and this is what actually leads to create more value in the system. Because if we look at it, what is happening with different technologies, combination of quantum computing, a lot of work I did in past 25 years ago. Now those things can be actually addressed. At that time, we didn't have the computing power to actually solve the problems. Theoretically, we could solve it, but computationally, we could not. But now today, we have come into that era that we can leverage quantum computing to solve some fantastic problems in science and technology. And then, of course, all these emerging technology or exponential technology that are evolving, that really needs a large amount of adoption of big data solutions. And in order to do that, we actually use a methodology called SMART approach. It has been published in other places, but it's more about simplifying the data ingestion to actionable insight generation, make the data search friendly. Most companies lack that, especially our industry certainly lacks that. And how do you actually connect the data sets, and how do we reduce the total cost of ownership and build solutions which are technology agnostic. They also give an example of a problem from cybersecurity, which was done almost 10 years ago, and still a solution is running in one of the companies in this DC area. When we actually analyze 7 terabytes of data per day to be able to predict denial of service attacks. And it was a combination of various big data technologies at that time. Since then, it has evolved, but it was one of the challenges that we found was you could not really use Hadoop to actually create patterns in a timely fashion. So in order to do that, we actually built a hacked up version of a Postgres database in front of a Hadoop so that we can actually look at the patterns in real time. But it was certainly much more valuable. And one of the interesting thing that came out of that analysis and that modeling was that you can actually figure out things that many people did not see, and actually build a new product out of it. And that became a revenue generating product in this case. And this was all completely done on pure pattern based strategy, like building patterns from the data and looking at can I predict the DDoS attacks, but at the same time able to look at what is happening to a certain website or a certain digital asset. And this is the value of big data analytics that can be actually leveraged effectively. This is another example that is published on mining unstructured data. And in oil and gas industry, the metrics is called non-productive time. If we are idle for whatever reason it may be, that's kind of a loss of revenue for the service companies, and a loss of value to the operators as well. So how do you actually reduce that? Most of the industry falls anywhere between 15% to 30% of NPT per year, which is significant amount of money. But by mining unstructured data, one can actually look at it and actually reduce that NPT. And in order to do that, one has to leverage the set of big data ecosystem, whether it's how to manage the data or how to create value on the left hand side. And these systems have to come together to actually create value. And when you do that, you leverage the data, the technologies, the analytics aspect of it, and then build an actionable insights rather than just dashboards. And you can actually change the whole spectrum of industry. And one of the reasons that, as I said, lot of projects fail. From my experience, I call them the lame reasons for failing. First of all, is the leadership, lack of knowledge of big data talent, the big data aspect, the lack of patience when it comes to pattern recognition. Even with the picture that I showed you, it would have been difficult for most people to find 13 animals in it. When we are talking about bigger complex things, it is even more challenging. The second part is that there are a lot of advisors who have never worked in big data, but they will tell you all kinds of solutions, and that causes those projects to fail typically. They sell technology but not solutions, and that's a big issue. And the third one is that data still in most companies sits in silos, whether it's data silo or cultural silos, and very difficult to build requirements when you don't have the path to transformation. And of course, the explosion of taps, as I call it, or the technologies, application, and products. How can we actually keep up with the pace at which they are evolving? And this is very important for us to really create value from it. In summary, one can actually build an innovative solution, and if one looks at the ecosystem, one is understand the whole big data spectrum, leverage the smart technology, build things on a platform, and then actually change the next generation of the industry that you are in. And this is just an example from oil and gas industry, but it can be done for any other industry. And having done that for other industries in the past, I know that this methodology works very well. With that, I thank you very much. Many of these things are published. You can actually look at it. What I try to cover today, what's the role of big data in industry 4.0, and what are its pillars, and why data pipelining is important, and then how you can actually measure the economic value in terms of how you create patterns and create enough efficiencies, and avoid the lame excuse that exist for failing projects, and think of this as a business paradigm. With that, I thank you very much for listening to me. Hope it was helpful to all of you.
It was great. This is the sound of applause out there, Doctor. Thank you very much. That was great in there. You can't hear the rest of the audience, but I'm sure they're doing that too. I'm going to take away. I got 13 animals. Do I win a prize? Is that how good is that? Am I lame on that? Is that?
So that again, I didn't hear the first part. I think I lost you.
I got 13 animals. How many? What?
Awesome. You can join my data science team then, Jim.
Ooh, great, cool, great. Couple questions from the audience, and I want to get to those just and before we get on to the next speaker in there. Can you explain what you more mean by big data as a business paradigm versus a technology play?
Absolutely. So in very simple terms, if you just go and buy a Hadoop system or deploy a Hadoop system, that is not big data paradigm, because it's just a technology to store the data. I think about 5 or 7 years ago, or 8, 9 years ago, there were articles which says Hadoop is big data or big data is Hadoop. That's not what it is. It is big data is how do I create value for my business? How do I connect my historical data? What can I learn from it? What can I modify in the current data that we are collecting? And are we prepared for the future data? Example is in manufacturing, in oil and gas or energy sector. If IoT sensors are becoming miniaturized, they are going to generate the data for us. If we deploy them, are we ready to actually ingest that data and create value from it now? Or are we going to wait to build a data model for 6 months after the data is collected? Hence, the big data is a business paradigm in that sense, because you have to be ahead of the curve rather than behind the curve.
Okay, yeah. And second question, we could go on. I want to start discussing this with you, but we got to get to the next speaker. But I want to ask the question from the audience. So, what are the important parts of an agile strategy?
Yeah, so see, agile strategy came from development side and things like that. But in an analytics world, one of the simplest thing is that can I add on data in different dimensions, right? So let's assume that you want to predict a failure of certain trucks or whatever it is, right? You may only have its driving history, but you may not have the driver's history, right? So you build a model based on driving history of the truck, and then when you get the different drivers who have been on that truck, then you actually can combine their history as well. So when your model becomes much more valuable. So as you learn about different elements of the uh, uh, of this problem, you keep adding on, so your model gets better and better, and eventually the model will reach an asymptotic limit where you can't improve anymore. And that is what agile means here. Because some people will say, oh, when we are talking about all the data, I don't know what all the data means, right? Because nobody knows exactly. So we can actually do incremental is maybe another word, but agile is a better word for that.
Yeah, thank you. That's the best explanation I've heard. You've got the driving, and then you've got the truck, and then you've got the driver, and you keep overlaying in layers and uncovering and discovering more.
Yep.
Fabulous, fabulous. Dr. Satyam, I wish we could talk more, but hopefully people will get you through the day, and hopefully we can connect with you on LinkedIn and get to hear some more great stuff from you. Thank you so much.
Thanks so much.
Fabulous. And thanks to the audience for the questions. It's been great. We have our next speaker coming up now.